You're watching the Intel Network and Edge V Summit series with our focus today on cloud-native NFV. In early 2014, AT&T committed to virtualizing 75% of its network functions, a daunting undertaking at the time. So what have been the key lessons from this virtualization journey, and how can container technology help achieve true cloud-native network functions? Well, joining me now to look back and ahead at network virtualization evolution is Brian Beardon, AVP Network Cloud Design and Delivery Management at AT&T. Brian, thanks so much for joining us.
Well, thank you, Guy. Pleasure to be here.
Now, earlier we heard from Intel about the potential of cloud native to meet the evolving demands of network infrastructure. So before we look back at AT&T's experience with NFV, are we now at a stage where cloud native is viable evolution to NFV and VNFs?
I completely agree with Jenny's comments. We always wanted to be cloud native when we started this, and it was tough with the technology at the time. And there's certainly some promising technologies that should make that more achievable, and it's certainly needed as we disaggregated our network and brought more vendors in smaller pieces. So operationally, we really need to get to cloud native.
Great. Well, let's look at AT&T's experience. 6 years ago, AT&T started its pioneering journey to network virtualization. Tell us more about the original approach you undertook.
MySpace is the infrastructure that provides the virtualization for the network functions, and it's certainly been a journey. The good news is we're in a really, really good spot. We will definitely hit our 75% by the end of the year as we set out to do. I'm not sure a lot of us believe we would be here, but that's the good story. We're shifting our focus to scaling the traffic on that environment, and we're making progress in that area as well. It's certainly been a journey. When we started back in 2014, virtualization technology was rather immature. It was also very focused at IT-centric workloads. IT workloads, they like to process bits and store them and retrieve them. Network functions, they need to just move bits really, really fast with very little latency. And at the time, infrastructure technology that's provided by OpenStack was not quite there. We had a lot of gaps in the networking space. We attached ourselves to a networking technology and open source community that looked really good on paper, very flexible, very feature rich. But in practicality, we never really achieved the performance we needed. So that was a huge challenge. We also, took OpenStack, brought it in locally, integrated in with AT&T systems, and we deployed it to many, many locations. OpenStack really wasn't focused on, multi-location installations. It was really more of a single data center approach. So we ran into a lot of challenges on how to manage the lifecycle of OpenStack in that environment. So it was very, very challenging, and we've had many lessons learned along the way, for sure.
So faced with all these issues, what happened next?
Well, about 2 years into it, 2016, we took a pause and reassessed where we were. We were running into some issues that were slowing us down from an infrastructure perspective. The first one is, we learned that if you want to use open source, you really need to have an open source first methodology. You need to work upstream with partners like Intel and Dell, solve the problems in the community, and then have the CI/CD pipelines to easily ingest the changes that occur in the community. What we had done by having OpenStack locally and modifying it locally, we had created a huge technical debt where whenever we wanted new features from the community, we had to backport them ourselves into the version we had. And we had over 200 locations. So it was very, very difficult to upgrade those locations with the approach we've been taking. So we've shifted gears. We now work upstream with like-minded partners like Intel and Dell, with other telecom providers. And we've been able to mature those open source communities for telecom use to help us in what we need to do. And the second thing we did is, with some of those same partners, we started an open source community called Airship. One of the issues we had with OpenStack is that it was really IT-centric and focused on single data center use, where in a network world, we have hundreds of locations. So we needed lifecycle management capabilities that would work in a geographically dispersed, multiple instance approach. So that's what Airship does for us. We took the OpenStack services, we containerized them. We use CNCF projects like Kubernetes to create this lifecycle management service, which supports complex Helm charts to deploy services. And we're now at a position where we can upgrade hundreds of locations within a couple of weeks. Most upgrades, about 80% of them, do not even impact the running tenants. So we're able to deliver infrastructure changes much more quickly. We're able to benefit from the open source communities at such a huge level that it's been fantastic. The next thing we did is we took a step back and we had picked a networking technology that was feature rich, that all of our network functions claimed they needed all those features. But we never were able to deliver those features in a performant or scalable way. So we went and looked at where the industry was. And what has happened over the last couple of years was that the industry was coalescing around a few technologies. One of them is SROV, the other one's OVS with DPDK for performance enhancements. Intel has been a huge contributor in that space, has solved a lot of the issues that we have in getting performance out of a network overlay. So we basically said, hey, we're just going to go with those two approaches. SROV, if you want really, really fast, low latency network capabilities, such as user plane type services. And then OVS, which is a little bit easier to use. It's fast enough, but it's very flexible, so excellent for most control plane type services. And then what we did is we went to Intel and said, you know, Intel, we don't want to have to bifurcate our environment. We don't want these computes for SROVs and these computes for OVS. We want the ability to run any workload anywhere. And they work with us, changes in their driver, changes in OVS and DPDK. We now have the capability of running those two technologies on any host in our environment, much thanks to Intel. The next thing we did is we found out that in our previous approach, since we had kind of created an AT&T specific infrastructure, that our network function vendors would show up at AT&T, and it was almost like we were in unit test mode. And the debug, fix, test cycle was just very, very long because they could not replicate our environment at their labs. With our network cloud approach, which is 100% open source, we have our network function vendors with instances of network cloud at their locations, so they can test. And when they show up at AT&T, we're able to immediately get to the integration work and not have to deal with fixing bugs that they should catch at their own location. So those things have really accelerated our ability to deliver the infrastructure that's needed for network functions.
So what now needs to happen? What does the whole industry need to focus on now to complete this journey?
Well, there's a few things we need to do. Fortunately for us, when we created Airship to be able to lifecycle manage OpenStack services, it gave us a lot of experience on really how to be truly cloud native. We've also, an early adopter of Kubernetes and the container technology, so our engineers are up to speed on what we need to do. And the gaps that exist today are slowly being closed. Intel's been a huge contributor, as has Dell. Basically, we need high performance networking with containers. Ideally, we'd like to do that on bare metal. So work with SROV integration into Kubernetes is happening. OVS DPDK support, the ability to have multiple networking technologies in a cluster. Multis is a CNI that Intel's one of the major contributors to, which is closing that gap. We've also pushed for IPv4, IPv6 dual stack support. It's basically in an alpha right now, so that's coming slowly but surely. So these are the kind of things that need to occur before we just say, hey, we can take containers and run with them from a network function perspective. So we're getting close. And I'm glad you said whole industry, because when we started back in 2014, we were by ourselves, and we learned a lot of things painfully. And after we started talking to a lot of our other providers of communications across the globe as we meet them in industry settings, we found they experienced a lot of the same things. So we've created a task force under the Linux Foundation and GSMA called the Cloud Infrastructure Telecom Task Force. And the acronym is CNTT. The focus of that group is to define specifications for telco-grade network function infrastructure. Stream 1 is all virtual machine based, and we have basically completed the specifications. We are in field trials with several infrastructure providers to get feedback to make sure the specifications were accurate and the conformance suites actually test what we wanted the implementation to be. So really good shape. And a lot of people say, well, why did you waste your time on virtual machine technology when, you know, everybody should be working on containers? Well, number one, virtual machines, they're not going away anytime soon. And, you know, to be cloud native doesn't mean you have to use containers. You can build cloud native services with virtual machines. It's just you have to adopt cloud native principles, and our network functions have yet to do that. I will say container technology makes adopting those principles much easier, and it's really needed because as we've disaggregated the network, we've increased operational complexity. And with cloud native, you want your services to be like cows, where if one goes away, you don't really care all that much. Another one steps in and takes its place. If you're finding yourself care and feeding your services like a pet, then you're not cloud native and you're driving up operational costs. So to us, if container technology is the fastest way to get to cloud native, we're all for it. As a community, we started with virtual machines because we wanted to have specifications and processes and conformance test suites that work. And we wanted to make sure that as a community, we could actually produce that type of documentation and processes. And using virtual machines where the technology is fairly well known made it easy to refine the processes. So we did that within a year, which is pretty fast in the industry community. We're now focused heavily on the container-based infrastructure. And I mentioned those gaps that we want to close. As a community, we're agreeing on what those gaps are, and we're going to put all of our resources behind the communities to solve the gaps in the same way. And we hope to be in at least initial field trials in early 2021, and I think we're in good shape to make that.
Well, Brian, thanks so much for talking to us about AT&T's virtualization journey and network cloud. And don't forget, you can watch more interviews and discussions on Cloud Native NFV right here as part of the Intel Network and Edge V Summit series. But for now, thank you for watching and goodbye.